On March 3, 2011, during the third day of the alfalfa harvest, a hay trailer became stuck in a muddy, snow-covered field. As the trailer attempted to cross the soft ground, its rear wheels lost traction and began spinning in place, sinking deeper into the mud. The surrounding snow made the ground unstable, making the situation worse. To free the trailer, workers first used another transporter. Then another trailer was brought in and positioned in front of the stuck trailer. A heavy-duty chain was attached between the two trailers. With careful coordination, the assisted trailer pulled while the driver of the stuck trailer gently accelerated. After several attempts, the tractor finally broke free from the mud. Once freed from the mud, the hay bales were reloaded and the haul continued. This activity highlights the challenges of field work in early spring conditions with melting snow and wet soil. The Terex Mini excavator is unloaded from the flatbed truck without the use of a ramp. First, the operator rotates the upper structure 180 degrees, positioning the excavator blade on the edge of the truck. The blade is then lowered into the ground, acting as a support. Next, the tracks are pushed back until the machine begins to descend. Using a crane and hands, the operator carefully lifts and controls the weight of the excavator as it touches the ground. The machine is completely lowered and safely driven off the truck. When the motorcyclist was driving at high speed on the road, due to unstable steering, the driver's front wheel hit the truck parked on the side of the road. The motorbike fell down after hitting the back of the truck. Both the driver and the two people sitting behind the motorbike after the accident were thrown off the motorbike and fell down. On the highway, a car was preparing to cross the road. Another car was going in the other direction at high speed to avoid the car crossing the road, lost control, and drove off the highway, crashing straight into a house on the side of the road. While being checked at a station, a hydraulic jack suddenly fails, causing the semi-truck to lose balance and overturn. The vehicle tips over onto its side, but all nearby workers quickly run to safety, avoiding any injuries. The bus drove straight into the path of the truck on a two-lane road without signaling or turning. The truck approached at high speed, and the driver noticed the encroachment and braked hard. The trailer shuddered, tires screeching and dust flying. The truck skidded sideways, inches from the bus. The bus swerved, avoiding a direct collision. The truck resumed straight motion, continuing forward a few minutes later. Both drivers braked to a stop, the truck shaking from the sudden movement. The tension grew heavy before both vehicles came to a stop, avoiding a serious collision. Vehicles were seen traveling on a highway in South Korea when the cars suddenly lost control due to black ice and crashed into guardrails. A man on the road tried to signal the vehicles, but the slippery road surface caused the car to lose control and continue to drive. Minutes later, another car approached and was unable to brake on the slippery surface, crashing into a tanker truck parked on the side. Then a car skidded and collided with the vehicles. The chain reaction continued as more cars, unaware of the danger, approached at high speed and skidded out of control. The icy road surface hindered traction, leading to a series of collisions that rapidly increased in number and severity within seconds. The Curtis Wright R3350 engine is manually primed with fuel, and oil pressure is built up using an external pump. The ignition system is checked before engaging the starter motor. After several rotations, the engine begins to fire unevenly. As more cylinders engage, the exhaust starts emitting white smoke. Gradually, the engine stabilizes, firing on all 18 cylinders, with smoke clearing and sound smoothing, signaling a successful start after 32 years. The radial engine startup begins with connecting an external battery and turning on the master switch. The operator checks the magnetos and primes the engine by engaging the primer pump. After verifying everything is clear, he engages the starter. The engine turns slowly at first, releasing some smoke from the exhaust ports. As the starter continues to crank, combustion begins in a few cylinders. Gradually, more cylinders fire until the engine catches and stabilizes. The operator adjusts the throttle and mixture to maintain smooth idling. Once running steadily, the engine produces a rhythmic radial beat and visible exhaust pulses. This sequence represents the second successful start of the Curtis Wright R3350-32WA radial engine on this particular morning, after 4 years of inactivity, indicating a well-preserved and functional system. The R-2800 engine is primed, and the propeller is rotated manually. The starter is engaged, causing the engine to turn over. After several rotations, ignition occurs and the engine starts. It stabilizes at idle, then accelerates to higher RPMs, demonstrating smooth operation on 100 SF aviation gasoline. At Traomania in Cascade on October 19, 2014, a large diesel engine demonstration showcased the startup procedure of a historical big engine. The process began with manual flywheel rotation, using a crank lever to gradually build momentum and ensure lubrication. Multiple operators coordinated the rotation to overcome the engine's initial static resistance. Once the flywheel reached sufficient speed, the decompression levers were engaged to release compression pressure from the cylinders, making rotation easier. With continuous cranking, fuel was introduced into the combustion chambers. A timed re-engagement of the decompression levers allowed the cylinders to compress and ignite the air-fuel mixture. Upon successful ignition, the engine began firing rhythmically. The operators carefully monitored its performance, adjusting fuel and air controls to stabilize the speed. As the engine warmed up, vibrations and mechanical noise increased, characteristic of large single-cylinder diesel engines. The exhaust system emitted dense smoke initially, which gradually cleared as combustion stabilized. The large flywheel continued spinning, ensuring smooth and consistent torque. The audience observed the raw mechanical power and robustness of early 20th century diesel engineering. This live demonstration highlighted the manual and physical effort required to start and operate a grand motor, reflecting the heritage and engineering prowess of historical diesel technology. The SAC-MMG To start the Douts MKH261 cylinder diesel engine, the operator first turns the large flywheel manually to bring the piston into the correct starting position. Compressed air is then introduced into the cylinder via a valve to initiate rotation. As the engine begins to turn, fuel is injected through the fuel line. The intake valve opens to allow air into the combustion chamber, followed by compression. The camshaft drives both the intake and outlet valves in sequence. Once fuel combusts, the engine fires and maintains rotation. The oil pump begins circulating oil to lubricate internal components. Simultaneously, the cooling water pump draws water from the cooling water tank. The cooling water control ensures proper flow to regulate engine temperature. As the engine stabilizes, its rhythmic sound and movement confirm successful operation. The operator closely monitors all systems throughout the startup to ensure a smooth and safe run. The Rolls-Royce Griffon MK58 engine is started manually using an external power source. As the starter motor engages, the engine slowly turns over, then fires up with visible exhaust pulses. After initial combustion, the engine accelerates steadily while emitting a deep, powerful sound. Both contra-rotating propellers begin to spin one clockwise, the other counterclockwise, demonstrating synchronized operation. Despite strong wind conditions, the 6-foot diameter propellers remain stable. The engine is monitored during the run-up for performance and vibration. Once stabilized, the engine continues running smoothly, marking a successful first startup with contra-rotating propellers. The operator opens the fuel valve and engages the starter. The 6-cylinder Alice Chalmers engine cranks slowly due to the cold 15 degrees Fahrenheit temperature and lack of preheating. After several revolutions, it fires up with thick white smoke from unburned fuel. The engine struggles initially but gradually gains speed. As the combustion stabilizes, the smoke clears and the idle smooths out. The generator, connected to the engine, begins running steadily, signaling a successful cold start despite harsh conditions. The startup sequence of the massive Duvant 6NN diesel engine begins with a thorough pre-check of the engine components. Operators carefully inspect the engine, verifying that all valves, fuel lines, and mechanical parts are in good condition and properly lubricated. The immense 6-cylinder inline flat engine, with a displacement of 950 liters and outputting 600 horsepower, weighs an astonishing 53 tons, requiring precise handling. Next, the operator primes the fuel system. Diesel fuel is gradually introduced into the injection pumps and fuel lines to ensure no air remains, which could cause starting difficulties. This priming is critical for smooth ignition, especially given the engine's size and age. Following fuel priming, the lubrication system is activated. Oil pressure builds steadily to protect the massive pistons and cylinders during startup. Proper lubrication is vital for this giant engine to prevent wear and overheating during operation. Once fuel and oil systems are ready, the engine's huge flywheel is prepared for turning. Due to the engine's scale, a powerful external starter motor or compressed air system is used to initiate the first rotations. The video shows the slow but steady turning of the crankshaft, allowing the pistons to begin their compression strokes. As the engine gains momentum, the operator carefully adjusts the fuel delivery. Diesel begins igniting within the combustion chambers, producing the distinctive deep rumble characteristic of large diesel engines. The machine slowly comes to life, with its mechanical components synchronizing precisely. Finally, the engine reaches its idle speed, running steadily and smoothly. Continuous monitoring ensures all systems maintain proper pressure and temperature, confirming a successful startup of this extraordinary piece of engineering. The startup begins by supplying compressed air to the national single-piston engine. This airflow initiates the piston's movement, allowing the engine to begin its cycle. As the piston moves, the engine ignites the coal-gas mixture, producing a very loud bang, far louder than speakers can capture. The powerful explosion drives the piston, ensuring smooth and continuous operation. The owner demonstrates this process live at the Piacenza Exhibition Center, showing the engine revving up and running steadily. The 2013 Radial tractor, equipped with an 18-cylinder Curtis Wright R3350 radial engine producing 4,000 horsepower and 10,000 newton-meters of torque, demonstrates its powerful movement in tractor pull competitions. When starting, the engine roars. The maximum torque pushes the tractor forward with great force. The many cylinders of the powerful radial engine fire in succession, creating the characteristic and powerful sound of a radial engine. When the tractor starts to pull, the large torque is transmitted through the transmission to the rear wheels, which grip the road surface tightly. The rear tires dig deep into the ground, creating the traction needed to pull heavy loads. The tractor accelerates steadily, despite the considerable resistance from the snowmobile it is pulling. The tractor's front end rises slightly due to the enormous torque and weight transmitted during acceleration. Throughout the run, the driver maintains control by adjusting the throttle and steering precisely to keep the tractor aligned with the track. The suspension and chassis absorb vibrations and stresses caused by the powerful engine and rough road conditions. As the tractor nears the end of its pull, it continues to exert maximum power until the sled reaches its limits. The tractor's dynamic movement reflects the balance between raw power, controllability, and mechanical strength required in tractor pull competitions.
And as you see, there's something to... Oh! A small fire. That's just for television. Just for television? Ha ha. Beautiful.
The starting process begins by preparing the stationary engine for ignition. First, the operator checks the fuel supply and opens the fuel valve to allow fuel flow into the carburetor. Next, the compression lever is engaged to pre-compress the air-fuel mixture in the cylinder. The flywheel is then rotated manually, creating the necessary momentum. As the flywheel turns, the ignition system is activated, generating a spark to ignite the compressed mixture. The engine fires and begins to run under its own power. Once the engine runs steadily, the operator adjusts the throttle to maintain optimal speed and monitors the lubrication system to ensure proper oil circulation. The compressor set coupled to the engine is then observed for smooth operation, confirming the engine is fully started and ready for its task.